Here we will see abstraction in Python. Abstraction is used to hide the internal functionality of the function from the user. The user can only interact with the basic implementation of the function, but inner working is hidden. That is, the user is familiar with what function does, but they don't know how it does. For example, when we use the smartphone for operating functions such as cameras, voice recorder or call dialing, we don't know how these operations are happening in the background. Or when we use the TV remote to increase the volume, we don't know how pressing a key increases the volume of the TV. We only know to press the plus button to increase the volume. Different benefits of abstractions are modularity. Abstraction promotes modularity by breaking down complex systems into smaller, more manageable modules. Each module can be developed and tested independently, which makes the overall code base more maintainable. Then reusability. With abstraction, we can create abstract classes that define common attributes and behaviors. These abstract classes can be inherited by multiple subclasses, which allows user to reuse code and avoid duplication. Then encapsulation. Abstraction helps in encapsulating the implementation details within a class. By hiding the internal working of a class, we can protect the data from being accessed or modified directly. This enhances the security and integrity of the code. Then flexibility. Abstraction provides flexibility, which allows user to modify the implementation of a class without affecting the code that uses it. This makes it easier to adapt and extend the functionality of a program as requirements change. And code readability. By abstracting unnecessary details, the code becomes more readable and easier to understand. It allows developer to focus on the essential aspect of a program and improves the overall code quality. In Python, abstraction can be achieved using abstract classes and abstract methods. Abstract method is a method that is declared but contains no implementation. It is just a placeholder that tells the programmer that this method must be overridden by subclass. And abstract class. A class that contains one or more abstract method is called abstract class. You cannot create an instance of an abstract class directly. There are two types of abstraction in Python: data abstraction and process abstraction. These two abstractions are achieved using abstract classes and methods. First is data abstraction. Here the original data entity is hidden via a data structure that can internally work through the hidden data entities. That is, it works for hiding data representation. To implement data abstraction, we will use abstract classes with abstract methods which define the interface without providing concrete implementation. Example is, a stack data structure can be abstracted, which hides the list or array implementation and provides a simplified interface for push, pop and pick operations. Benefits of data abstractions are, it makes the code cleaner, more manageable and easier to maintain by reducing the complexity. And process abstraction. Here implementation details of a process is hidden. That is, it works for hiding how the process is executed. Implementation of process abstraction is similar to data abstraction. That is, abstract classes and methods can be used to define the process interface without showing the implementation detail. Example of process abstraction is, a data processing class can be abstracted which hides the specific algorithms and steps involved in processing data and exposing a simple process data method. And benefits of process abstractions are, it reduces complexity, improves code readability and allows developer to focus on a higher level logic.